I know that theta is in quadrant 4. And I know one of the trigonometric values. I know that tan theta is equal to -4. And I might just be given any one of them, but I might not know the others. But I know the tangent theta is -4. So I need to find the 5 other trigonometric values. Okay. Oh wait, it says it's in quadrant 2. Okay, not quadrant 4, it's in quadrant 2. Unless you'd like to do it in quadrant 4.
Not.
Yeah, it'll be the same problem. Okay, quadrant Q2. Queen Elizabeth 2, QE2. Okay. All right, is that right? Yes, that is correct. Okay. So again, I'm going to draw a circle. And I know that my angle is somewhere over here in quadrant 2. I don't know where it is. I don't really care. I just need to put something in there for me to be able to visualize it. And I'm going to drop my perpendicular here. And I know that the ratio of sine opposite, so here's my reference angle right there. I should make that clear. I need to know which is my reference angle from the terminal side down to the x-axis. I know that my side opposite is 4, and that my side adjacent is -1. And again, I need to find the hypotenuse in order to get the values of all of my functions here. So my hypotenuse is going to be 4 squared plus 1 squared, or -1 squared, same thing, is equal to h squared. I'm going to use a Pythagorean theorem. So I have, what would this be? 16 plus 1 is equal to h squared. So h is equal to radical 17. And there's not going to be anything I can do to simplify radical 17. Yes? Good? Okay. So let's do our values. I now know this is radical 17. Sin, cos, tan, cosecant, secant, cotangent. And I'm kind of sloppy when I do this, because really, sine, cosine, and tangent, cosecant, secant, and cotangent, they have to have an argument. They don't exist in and of themselves. So really, I should be, since I'm dealing with angle theta, I really should have a theta after each of these. There's no such thing as like cosecant without an argument or cotangent without an argument. It has to have an argument. I'm just a little bit lazy. So the sine is going to be my opposite over the hypotenuse. So my sine is going to be 4 over radical 17. Sine 4 over radical 17. I'll multiply to rationalize my denominator. And I get 4 radical 17 over 17. And there's nothing I can do with that.
I have
Yes?
a question. Do we need to have it memorized, like the 6 thingies, like the 6 trigonometric functions?
I'm not sure I understand your question.
Like, do we need to memorize the order?
Yes.
Okay.
Yes. You need to, when you're writing out the 6 trigonometric functions,
Like, you need to write it like that.
it has to be like this. Sine, cosine, tangent, cosecant, secant, cotangent.
So by memory, like, you're not going to give it to us?
I don't think so.
Okay.
No, so you should know that, right? Because sine is associated with cosecant, cosine is associated with secant, tangent is associated with cotangent, and sine over cosine equals tangent.
Mm-hmm.
So you just have all this information in this nice 6-item block. And I also know what my positive or negative signs are going to be for each of these values, because all students take calculus. Okay, that means if I'm in the second quadrant, the only one that's going to be positive is sine. I already know my cosine and my tangent are going to be negative, and I know that my secant and cotangent are going to be negative. So I can just fill that in right off the top. So my sine I came up with 4 radical 17 over 17. So sine is equal to 4 radical 17 over 17. My cosine is going to be negative 1 over radical 17. My adjacent over the hypotenuse. So cosine negative 1 over radical 17. So I'll rationalize that. So it's going to be negative radical 17 over 17. My tangent is going to be my sine over my cosine. So I can see, looking at sine, well, I already know what my tangent is, right? I can see
Use opposite over adjacent and it would be
it would be easier. So you like doing opposite over adjacent, you like 4 over negative 1. Okay, that's fine. But I know an even easier way to know tangent. It was given in the problem.
Oh.
It's hoping tangent was negative 4, that's how we started the
Well, I think
problem.
that's a great discovery by getting it.
No.
No.
No, yeah.
How did you know that it would be negative 1 on the bottom and that the other terminal side would be 4? Did it say that on the problem or did it?
Because it told me, okay, so Lola asked a question. How did I know that this was going to be negative 1 and that side was going to be 4? Because it told me that the angle was in quadrant 2. So if I'm in quadrant 2, my x value is negative and my y value is positive. Yeah? Okay, good. Was there a question? Okay, good. My cotangent should be pretty easy. Negative 1/4. And my cosine theta, what was it here? My cosine was negative 1 over radical 17. If I take the reciprocal of that, it's just going to be negative radical 17. So that's going to be, that was this one here, secant, negative radical 17. And my cosecant is my sine flipped upside down. So here's my sine. I'm going to flip it upside down. It's radical 17 over 4.